Hello everyone, welcome back to this lecture series on digital system design. Today in this video, we'll be seeing how to reduce any given Boolean function using the second method, that is Quine-McCluskey method or QM method. In the previous videos, we have seen how we can simplify the given equation using K-maps, 3 variable, 4 variable K-map. Today we'll be seeing the same thing, that is reduction of or simplification of the given Boolean function using the QM method. This is advantageous compared to the K-map in a sense that if I go for higher number of variables, the K-map method becomes very complicated because you'll have to write a lot of K-maps for just one problem. Till now, we have seen 4 variable K-map where you have this 4 cross 4 or 16 cells in one map. If I go to 5 variable, then I'll have to draw two such K variable maps, two such 4 variable map to get a 5 variable simplification. So as and when the number of variables increases, the complexity of using K-map also increases. So to avoid that, to overcome that, we have come across with the second method, that's QM method. Though it's a tabular method, and there is still some complexity involved in it, but compared to K-map, it is much easier and less time consuming when we go for higher number variables. Till 4 variable, K-map is the best option, I can say. But sometimes what happens, there are chances that you will miss some of the mappings, some of the groupings. You might not be sure, you cannot be sure that these are the groups or only possible groups available. So you might miss out on something. Instead of going for a quad, you might end up with pairs. So QM method has very little uh, options for you to make error in that case. You're not going to group something, you're just going to simplify it using a tabular column. Okay, so I'll take an example and explain how exactly this is done. There are other special cases also in this QM method. I'll explain each one of them. Okay, so to begin with, we are going to look at QM method without taking into account the don't care terms initially. We just have the min-term expression and we are not talking about don't care in right now. Okay, so I'll just explain the procedure first, then we can go on with this example. I'll explain the procedure, then I'll give you some questions to solve which you can work out as exercise. Okay, so let's take this first example. I've taken a 4 variable function with min terms. This is in SOP format, right? So to begin with, uh, as I just mentioned, the QM method is the tabular method. So in the tabular column, the first thing you're supposed to do is any number that is given, whether it is 4 variable or 3 variable, you need to know how to write the binary representation of the given number. Okay, any decimal number, how do you represent in binary? So you should know that. And with the help of that binary representation, you'll be able to write the tabular column next. Okay, so the tabular column, the first column, I'm going to mention the min term. And then in the second column, I'm going to write the binary form of that particular min term. Sorry. So the first column will be about the min term. Second is binary representation. Min terms are nothing but the numbers that are given here. Whatever numbers are mentioned here, that you have to list it out and you have to write the corresponding binary form of that particular number. Now, since in the question they've given you 4 variable, which means to represent any decimal number, I need 4 binary bits. Okay, so if I have to, and you can name them as, since they've given it as ABCD, I'll take it as ABCD itself for binary. So if it is 0, I will have to represent it with 4 bits in binary form, that is 0, 0, 0, 0. I hope all of you are familiar with binary representation. If I want to, how do I write it in binary? I have to write it as 0, 0, 1, 0. Similarly, next you have 3. It is 0, 0, 1, 1. The next number that is given here is 6, 0, 1, 1, 0. Then 7, 0, 1, 1, 1. 8, 1, 0, 0, 0. 10, 1, 0, 1, 0. 12, 1, 1, 0, 0. And 13, 1, 1, 0, 1. So these are the numbers given in the question, and this is a corresponding binary value that you have to write. Okay, now this is not your main table. Please note, I've just written the binary representation of the given number. But in the main table, what you're supposed to write is, you have to write the min term in a particular order. And what is that order? You have to write it in ascending order of number of ones in each of these binary value. You have to group them. All those numbers which have just one will be under one group. Next, in the next group, you have to put those numbers which has two ones in their binary representation into one group. Okay, so on, you have to write the numbers in the order of their increasing number of ones in their binary representation. So I'll write and show how it is done. Now, out of all these numbers, the least number of 1 comes in the value 0 with no ones, right? So this alone becomes one group. The binary representation of that is 0, 0, 0, 0. Okay. In the next group, I have to go to the next number of ones. That is, here there is no one, that is 0 ones. Next, I have to look for numbers which has only one value here. Okay. So I have the number 2, which has only one single one in that. Then if I look at it, number 8, decimal number 8 also has a single one in this. And yeah, only these two numbers have single one in them. So these two become one group. Okay. Next, you should go to two number of ones. Two ones should be there in the binary value. Such decimal digits you have to group it together. So I have completed 0, 2. Next, I'll look at 3. 3 has two ones, so I'll take that here in the third group. 0, 0, 1, 1. 6 also has two ones. 7 doesn't have two ones. I'll skip it. 8 is already done. Next comes to 10. 10 has two ones. 12 also has two ones. 13 has 3, so I cannot take it and skip it. So these numbers will become the third group, which has two ones in their binary representation. Coming to the next one, after two ones, it is three ones. I have done 2, 0, 2, 3, 6. Coming to 7, always go in the order and check, okay? So now here when I come to 7, it has three ones. I'll put it here. So okay, and then 8, 10, 12 are done. Coming to 13, it has three ones. Only these two numbers were there with three ones, so this is done with the group. And now, if at all in the question they had given you 15, which means it has four ones, so this would have been written separately in the next group, like this. Okay, so that is how we have to group. The tabular column for QM method initially starts with grouping of the numbers based upon how many ones are there in their binary representation. Start with the least number of ones up to the highest number of ones. So those which have same number of ones will be grouped into one group. Okay, this is your first part of the table. Once this arrangement is done, next you have to go for simplification part. Okay, I hope this is clear. If not, you please rewind and then again check this part again, because it's a very important part in this problem. This is where everything begins. If this order is messed up, then the entire solution will go wrong. So be very sure that you've understood this step in the problem. Okay. Now coming to the next step, I just put a demarcation here. Again, the continuation table, you don't have to write it separately. Okay. You have a very big sheet here. You can just continue one after the other in different columns. But the column names remain the same. Minterm and their binary representation. Okay, so in the next table, the next part of the table, how you're going to write the minterm. So please listen carefully. Now I have different groups, right? I'll call this as group 0, group 1, this is group 2, and this is group 3. So what you're supposed to do now is adjacent groups, you have to compare the numbers and see which two numbers have a binary value such that they are differing in only one position. Okay, so adjacent groups you have to check. For example, first I'm going to compare group 0 and group 1. That is, I'm going to compare number 0 with 2, and I'll see if their binary representation is just one. Is there just one difference between the binary value? If there is only one step change happening, or are there more than one bits changing? Okay, if there is only one bit changing, then you can group them together. But if there are more than one bit change happening, then you cannot group them. You have to just leave it there as it is. Okay. So now first, let's take group 0 and group 1. I have to compare all the elements of group 0 with all the elements of group 1. So here I'm going to first compare group 0, element 0 with group 1, element 2. Okay, so I'm comparing the 0 and 2 binary values. You see, this position is same, 0, 0. This position is also same. Here there is a change happening from 0 to 1, and the last bit is same, which means out of all the 4 bits, only one bit change is happening. So I can put them together, group them together. Okay, so the first minterm I'm getting in the second table is 0 and 2, their binary values changing by only one position, so I can group them together in the second table. After that grouping, which bit changes? Now, out of the 4, the first 2 and the last is same, right? So keep it as it is. Whichever is changing, it means it gets cancelled. So there you have to put a dash. Whichever bit has changed from 0 to 1, you're going to just nullify it. This is exactly what you did in K-map. When you were writing the equation in K-map, if both these were grouped, what did you do? This is A bar and A, correct? A number with its complement. You just eliminated it from your result. That's exactly what you're doing. If it is changing, you're not going to keep it here. If it is not changing, keep the values as it is. But if it changes, you just remove it from your equation. Okay, so that is what you have done. And what is the condition for this? There should be only one change, one position change happening here. That is your gray code. Okay. Now, 0 with 2 comparison is done. Next, you have to do 0 with 8. Okay, one more thing. Every time you do the comparison, and if you see that the group was, you were able to form the group, then those numbers you please make a, you mark or put a tick in front of those numbers saying that they have been used. They have been grouped. Okay. 0 and 2, you were able to make a group out of these two numbers. You put a tick in front of them. Just to show that it has been used at least once. Okay. Now coming to the next one, next option, 0 and 8 is compared, and you see there is only one position change happening between 0 and 8, that is in first position. So again, you can combine these two into a group since there is only one position change. And where is that change happening? It is happening in the first one. 0 is changing to 1. So whichever changes, that will be marked dash, that is there is no uh, variable there. You're going to eliminate that variable. Remaining three values are exactly the same. You keep it as it is. Okay. And since you have used 8 also at least once here, I'll take that also. Okay. It shows that this has been grouped at least once in the procedure. So now we are done with comparing the first two adjacent groups, that is group 0 and group 1. Next, we'll go for group 1 and group 2. So all the elements in group 1 should be compared with all the elements in group 2, and then you have to write down whichever has only one bit position change happening in them, that will be grouped together. And if at all it is you're able to group it, you have to just put a tick mark in front of it. Okay, so I will start again. You're going to compare 2 with all this and see if any grouping can be done, and then compare 8 with all of them and see if any groups can be made out of it. So first I'll start with 2 and 3. So you see 2 and 3, when you compare, 0, 1 remains the same, whereas the third bit is changing, fourth bit is same. So you have only one bit change happening here. Sorry. I'm sorry. One second. Yeah. There is this first bit is changing between 2 and 3, 0 to 1. Remaining all the three bits are exactly same in both 2 and 3. So which means only one bit is changing. You will have the option to group them. And one more thing, every time you're done with two groups, you put a line separating them from the next two group comparison. Okay. So then now the second part, 2 and 3 were compared, and you found out that the first three bits are same. The least significant bit is changing. So you are able to group it. And after grouping, what is the result you will get? Whichever bit is same, keep it as it is. Which has changed, you eliminate it. Okay. So since 3 has been used once, I can put a tick in front of it. It has been used. Okay. Next, we'll go to uh, 2 and 6 comparison. So 2 and 6 also you have only one bit position which changes here. So I can group them together. And the number is going to be 0 dash 1 0. Okay. Whichever bit is changing, that bit you nullify, you just eliminate it. Remaining bits you write as it is. Okay, and as you can see, 6 has been used, so I'm going to tick it. Next, I have to compare 2 with 10. So 2 with 10 also it is possible because 0, 1, 0 is same. Only the first MSB bit is changing between 2 and 10. I can combine them. So it becomes dash 0, 1, 0. Okay. Whichever bit has changed, I have nullified it. Remaining bits are written as it is. And once again, you can use a different color pen so that you'll not be confused later whether it is uh, used or not. Coming to the last comparison of 2, 2 with 12, you see when you compare 2 with 12, there are two positions that are changed. 0 to 1, 0 to 1. You cannot group it now. As I told you, the condition is there should be a change happening in only one position. Anything more than one cannot be grouped together. So 2 and 12 now cannot be made into a group. So just skip it. Okay, so you're done comparing 2 with all these numbers. Until now, you have not been able to group 12 with anything, so I'm not going to put a tick mark in front of it. Okay, now the next number is 8. 8 needs to be compared with all these values and grouped together wherever possible. So first I'm going to compare 8 with 3. If you see there is 1, 2, and 3 position changes, so you cannot group it. Next comparison 8 with 6. Again, there is 3 position change, you cannot group it. 8 with 10, only one position change is happening, which means 8 and 10 can be grouped. And the grouped answer is going to be 1, 0, dash 0. Whichever bit is changing, that bit needs to be eliminated. Okay. Next, since 10 has already been used and I have ticked it, I don't have to put a tick again. It means that you have used it. Okay. Next, last comparison 8 with 12. 8 with 12 also there is only one position that is changing, so I can group it, and that value will be 1 dash 0 0. So you're done with all the comparisons of G1 and G2. So this is it for the second set of comparison. Next, and one more thing, in the last comparison, you were able to use 12 also, which means you have to put a tick at the 12. Now coming to the last two group comparison, again compare 3 with these two numbers, again 6 with these two, 10 with these two, and 12 with these two. So we'll start with 3. 3 and 7, yes, it's possible to group them. There is only one position change happening, that is in the MSP, from MSP, the second value. Okay, so since you have used 7 now, for this grouping, I can tick it. Next, I'm going to compare 3 with 13. 3 with 13 is not possible because you have 1, 2, and 3 position change happening. So you cannot group it. So 13 is still not used. So keep it as it is. Next, 3 comparison is done. Now next I have to go for 6. 6 and 7, yes, it's possible. 0, 1, 1, dash. It's already ticked, so you don't have to worry. Next, 6 with 13. You have three position changes between 6 and 13, so you cannot group it. So 13 is still not used, so don't tick. Coming to the next, 10 with 7. 10 with 7, you have 1, 2, and 3 position changes. Cannot group it. 10 with 13, you have 1, 2, 3 position. Again, you cannot select it. Last, 12 with 7, 1, 2, 3 position change. You cannot group. 12 with 13, yes, you can group them because there is only one position change happening in the last bit. So the answer is going to be 110 dash. Okay, now we were able to cover even 13, so you can take it. I hope this is clear now. Between the adjacent groups, compare all the numbers of one group with all the other numbers in the other group. And whichever two numbers have only one bit change in them, you can group them together. If it is more than one bit, you don't have to group them. And after grouping, how do you write the second binary set of representation? Whichever is changing, which bit is changing, no? Only that bit will be eliminated. Remaining bits will be kept as it is. Okay, this you have to continue for every adjacent group. And every time you're done with the two group comparison, you separate them. Okay, again, this becomes group 0, group 1, group 2. And you have to continue this table, comparison table, until you reach a state where no further elimination can be done. Okay, so I hope this is clear now till this point. In case you have some confusion, some doubts, you please replay this video again from the beginning and check the Just go through it again, okay? Till this step. So you are done with the second table. We'll move on to the third part. Again, the titles remain the same. You are going to find the minterm and the binary representation. Now we are going to do the comparison between the new groups that you have formed between G0, G1 and G1, G2. Okay. And here, one easy method for you to compare is look for same place eliminated variable bit. For example, now I have to compare G0 with G1, right? The values of G0 with all the other values of G1. So the first number I am taking is 0, 2, which has a dash in the second position, second bit position. So out of all these numbers, you look for a number where it has a dash in the second position and compare that and see if the value is changing only by one position. Okay, so here there is a dash in the second position. So I have to look for a number which has a dash in second position, and that number is here. So compare 0, 0, dash, dash, 0, 0, 1 to 0. There is one position change happening. So I can group these two numbers together. Okay, so finally my minterm is I am taking 0 to group and combining with 8 and 10 group. Okay, I'm taking this number and combining it with 8 comma 10. And there is only one position change happening. The dash is in the same place. There are zeros in the same place. Only the MSB is changing from 0 to 1. So your answer is going to be whichever is changing, dash, the numbers as it is. Rest of the numbers as it is. Okay. And this time you were able to cover 0, 2 and 8, 10. So tick. Whichever you have used for grouping, you tick them. Okay. Next comparison. You see there was only one number out of all this which had dash in the second position. So you don't have to sit and compare this number with all of them, right? It is easy for you to just look for the same position elimination. That will be simpler for you. So next I'll go for the second number 0, 8 and see which number from this group has a dash in the MSB position. Not this, not this. This has, right? This has a dash in the MSB position. So compare these two. There is a change happening in only one place. So I can combine this 0 with 8 and 2 with 10. So this dash as it is, 0 as it is. This 0 is changing to 1 here. So dash and the last 0 as it is. Okay. So now you can take these two since you have used it. This and this number. You cannot compare any other numbers because they don't have common positions for dash in this group and this group other than these two possible groups which you have currently done with. Okay, which means no other grouping is possible in these two adjacent groups. You can stop here and go to the next two group comparison, right? So now we'll see I have 2 comma 3 number with the dash in the LSB. I have to look for a number which has dash in LSB in the G2 also. I have two numbers which has dash in LSB. Compare these two and see if there is only one position change happening. If yes, then you can group them. Otherwise, you have to just let them be. So if I take 2 comma 3 and 6 comma 7, they have dash in the same position, and also there is only one value that is changing. So I can group them together. So I have 2 comma 3 comma 6 comma 7. So their values will be 0 is same, but 0 to 1 change is happening. 1 is same and there is a dash in same position. So you have been able to use these two numbers. Sorry. 2, 3 and 6, 7 were grouped. You also have a dash in the last position in this number also. Just check if you can combine them. There is a dash, but there is a change happening in this, and this. Three position changes happening between 2, 3 and 12, 13. So you cannot group these two. There should be only one position change. So this is eliminated. You cannot use it. You cannot group it. Okay. Next, we'll check for the second number, which has elimination in the second position from MSB. Look for the same number here. Same position dash. So these two have dash in the same position, and there is only one bit changing. So I can combine these two, 2 comma 6 with 3 comma 7. Okay, so 2 comma 6, it has 0 and hyphen, and then 1 in the same place. 0 to 1 change is happening, that is hyphen again. Okay, so you were able to group these two values, this and this. Now what else is left? So you're able to cover all these values. You have one more value here, 1 dash 0 0. See if you can combine with any one of them. You have these two numbers are in the same, they have hyphen in the same place, right? But they are changing in 1, 2, and 3 places. So I cannot group it, which means this number and this number, I was not able to group them. So these two are left out now. Okay. I was not able to combine it with any other number. So they are left out, and I'll have to keep them as it is. I cannot tick it. Okay. I don't have the option to tick them now because they have not been used even once in the grouping, right? Now, coming to the last table, further simplification can be done if you have, this is one group where you have two similar numbers. This is another group, but you don't have hyphen in the same places, which means I cannot group it. We are changing in all the 4-bit positions, correct? They are not same in any bit. They're changing in all 4-bit, which means further simplification cannot be done. I'll have to stop this table at this point. Further simplification cannot be done. Now, one more simple thing is you have same numbers in both of them. That's why you're getting same result. Only the order of the number changes, but the numbers are still the same. That particular group has same numbers, so your output is going to be exactly the same. Okay. The same thing is happening for the second group also. I hope the this particular procedure is now clear. I'll just repeat quickly. To begin with, you have to arrange the given numbers in a order such that it will be in the ascending order of the number of ones in their binary representation, starting with 0 ones to maximum number of ones. Same number of ones, those decimal values which has same number of ones will be made into one group. Like that, you have to separate them into different groups. That will be your first table, first part of your table. The second part of the table is compare adjacent group, and whichever number has one position change in them, you can combine it together and write the result. How did you write this result? Which position is changing, that will be eliminated, and remaining positions will be kept as it is. So this continues for adjacent groups. First G0, G1, all the numbers are compared. Wherever grouping is possible, group it. Otherwise, you keep it as it is. And at the same time, when you get a group, every time you are able to make a group, you tick those numbers which have been used there. Please don't forget this step. Okay, this is very much important. Don't miss it. So immediately once you group them, you tick that number, whichever has been useful for making a group. This table again continues. Again, you have different groups here. Combine them, compare them. One position change is there, then you can come make it a group and write the simplified binary representation. And again, every time you are using a number, please tick it. Okay, and whichever has not you were not able to use it, you put a cross there, or you leave it empty. But you should know that there are some numbers which are left out. Remember it. Okay, so it's better you put a cross so that you will know when you come back and look, you will know these are the numbers which have not been used even once in the next level group. Okay, once you reach a position where no further simplification or combining can be done, you can stop writing this table. Okay, so this is about the initial part of the problem. Now coming to the next step, I'll have to write one more table here, which will have a column called prime implicants. Okay, and then another column which will have all the min terms, all the min terms that are given in the question. Okay, so in the prime implicants, what you're supposed to write is whichever in the entire first table, whatever numbers are not ticked, those numbers you have to write under prime implicants. Okay, under prime implicants, you can make two columns. Okay, whichever numbers you are not able to tick, which is left out, all those combinations should be written here, listed here. Okay, I'll start from the last part of the table. So here you see whether you write the first number 0 to 810 or 08 to 10, both have same value, right? So you just write it once. Don't repeat both the numbers. Don't write it again and again. Okay. So just write it once. 0, 8 to 10. This was you were not able to further group it, right? So keep only this number as it is. And now what you have here is how you have to write the expression for this. Okay. Uh, I have told you in the initial table, binary representation, I have taken the variable as A, B, C, D, correct? If it is 0, you write it like this. And how do you write the expression for that? A bar, B bar, C bar, and D bar. If it is 0, you always take a complement of that, correct? Now, exactly same thing you have to write. All the binary values what you have written, you have to write it in the equation format. And how do we write it? Wherever there is a dash, which means that variable is not there in your equation. Okay, and if there is a 0, you take complement of it. If there is a 1, you write that variable as it is. So here, if you look at this table, binary representation of A, B, C, and D. There is a dash for A, which means there is no A in your answer. For this particular term, there is no A. Then there is a 0 for B, which means your answer will have B bar. There is dash for C, so there is no C. There is 0 for D, which means your answer is D bar. So what is the equation you're getting for 0, 8, 2, 10? B bar, D bar. Okay. Now coming to the next number, this was the other number which was not used in any group. Both are repeated. Write it only once. I'll take this 2, 3, 6, 7. And I have to write the expression for this. Where there is 0, it is a complement. It is a dash. That variable you don't write. If it is a 1, write it as it is. So this is A, B, C, D. B is not there, D is not there because there is a dash in these two positions. For A it is 0, so it becomes A bar. For C it is 1, so it will be C as it is. Okay, that's how you write the equation from this binary representation. Now from this column, these two numbers are done. Now move back to the second column and see where which numbers are not used or are marked as cross. So there are two variables which are not used, right? Two set of groups which have not been used in the grouping for the further table. So you have to now list these two also here, which means 8, 12 also was not used. So list it here. And for the expression, it is 1 dash 0 0. So A, there is no B, C bar, D bar. And also the last one, 12 and 13 was also not used. So mark it include that also in this table. And the equation for that is for A and B it is 1 1, so A B. For C it is 0, so C bar. And for D it is dash, so don't write D. Okay. So from this table there were two numbers, two groups which were not used. So I have listed them. Come to the first table now and see if there are any left out terms. All of them are ticked, so I don't have to include anything from this table. Okay, so I hope you have understood how to write the prime implicants. Here you have to list all those groups which have not been used even once. Or another way I can say those groups which you have not been able to tick. Okay, so all those groups you have to list here. That comes under prime implicants. And write the corresponding equation also. Now coming to the second part of this table, min term. In the question, whatever values they had given you, these numbers, you have to just list it in the same order. Not in the order in which you have written that in the table. You just write it in the same order and what they have given in the question. 0, 2, 3, right? So instead of writing it as 0, 2, 3, I'm writing it as M0, M2, M3, M6, M7, M8, M10, M12, and M13. Small m here stands for min term. Okay, min term number 0, 2, 3, 6, 7, 8, 10, 12, 13. Those are the numbers. I've just listed them as it is. Whatever was given in the question, the same terms I've listed it. Okay. When you're drawing, please draw a neat table. I'm not used to this XP pen. So it's a little bit messy here. Okay, let it be. Right. Now, the next part is once you are done with this table, you're ready with this outline. The next thing you're supposed to do is place a cross mark under those minterm numbers which comes in this group. Okay, for example, in the first one, I have used 0, 8, 2, and 10. So under these numbers, I'll put a cross. So I have used 0 for this grouping. Then 8 is also required, 2 is required, 10 is required. So under those minterms, which whose numbers are mentioned in the group 1, I'm going to put a cross there or an in. Same thing repeat for the others also. In the second one, I need 2, 3, 6, and 7. So 2, 3, 6, and 7. In the third one, it is using only 8 and 12. So corresponding to the third one, I need 8 and 12. The last one, it needs 12 and 13. 12 and 13. Okay. So how many ever minterms you are left with, how many ever prime implicants you have got, corresponding numbers, you just put a cross mark here. Whichever number you have used here, now under that number, you put a cross mark. Okay. That will be your first step in the second table. Now, the next step is you have to now circle those X, those column where only one X is there. Okay. For example, if I take the first column, this X, there is only one X in this column, so I'll circle. Coming to the second column, 2X is there, so I don't have to worry about it, leave it. Coming to the third column, there's only one X. Next column, only one, only one. Here 2, so I'm not going to circle. Here there is only one, here there are 2, here only one. So in those columns where only one X is there, that X you have to circle. Okay, this will be the second part. So first you have listed out all the prime implicants which you have not ticked in the previous table. And once that is ready, under the minterms, whichever values you have used for the grouping, put cross mark under that. And the third is whichever column has one X, circle that X. If you have more than one, don't touch that. If you have only one X in that column, circle that X. Okay. Now, wherever you have circled X, that corresponding row value will be there in your answer. I have a circled X in the first row, so this term will be there in your answer. I have circled X in the second row, so this A bar C should also be there in the answer. And I also have a circled X in the last row, so A, B, C bar will also be there in my solution, which means my final answer will be B bar D bar less A bar C less A, B, C bar. Okay, so all the circled, all the rows which corresponds to circled X will be there in your solution. Those minterms or implicants should be there in your solution. Okay, but this is not the end. There is one more thing you have to confirm, and that is just with the help of these three terms, were you able to cover all the minterms of the given question? Okay, the last step you have to check, you have to verify is you got the answer, right? You have these three terms in your answer. Now you have to make sure that just with these three terms, you will be able to cover all the minterms given in the question. How do you check that? For that, what you have to do is, now the first term that is there in your answer is B bar, D bar. And what are the numbers for that? 0, 8, 2, 10. So tick them here on the above top. 0, 8, 2, and 10. These four numbers were covered in the first group. What is the second term in your answer? A bar C. A bar C corresponds to 2, 3, 6, and 7. So 2 is already ticked. 3, 6, 7. Done. Last term you have in the answer is A, B, C bar. Corresponding value is 12 and 13. So tick this 12 and 13. Now you see whether all the minterms are ticked. If yes, then this itself is your final answer. Okay. So this is the last step you have to verify. If you forget this step, then you may end up with a problem whose solution, what you have got, might not be a complete solution. Okay. So please don't forget this step. Once you have got the important terms, final answer, check if only those terms will be sufficient to cover all the numbers given in the question. If it is covering just like in this case, then no problem. This will be your final solution. If not, then there is a additional step you have to perform to complete your answer. Okay, so I'll take up that example in the next video, and I'll explain how that is done. But for now, I hope the procedure is clear. If not, please go through this video again and again until you're confident in solving this problem. I understand this is a little bit complicated compared to your K-map. K-map grouping is much easier and less time consuming. But QM method, it will be more accurate compared to your K-map, because you might end up missing some group there, or you might falsely take a lower number group, even if there was a possibility of getting a higher number group. Okay, you can still verify your answer using K-map. You will be ending up with the same solution. Okay, because for this problem, since all the midterms are covered with this expression, even the K-map is going to give you the same solution. So you can always, once you have solved QM method problem in the exam, you can take 2-3 minutes and solve the same question using K-map just to verify your answer. Okay, both of them will give you the exact same solution. Right? So that's it for this lecture. We'll take up more problems on QM method, and we'll try to solve more questions on this. Thank you.